So let's get started with our forces and free body diagram notes. So the first thing we want to do is talk about what is a force. Well, we're going to define a force as a push or a pull on an object. Anything that pushes or pulls an object is going to generate a force. And again, right here, we can just see a picture of somebody pushing on a door and somebody pulling on a door. So this is a very simplified way of talking about what a force is able to do. So again, forces are either able to push an object or pull on an object. And again, here's just a picture demonstrating that. And I'm sure that this has all happened to us, where we try to push on the door, but it really says pull. Super embarrassing, but let's be honest, it's definitely happened once or twice. So now we want to start talking about different types of forces. The way we're going to talk about these forces, though, are first identifying what type of force it is, and then defining what that force does. So the first one we're going to talk about is friction, and friction is a contact force. What that means is that you must be in contact with an object in order for friction to exist. Friction is defined as a force that is opposite when the object slides across a surface. So for instance, if I have a box right here and it's moving to the right, so it has some velocity to the right, friction is acting on this box in the opposite direction. So I would have friction acting in the opposite direction. And friction also is just a force that slows down objects that are moving. The next force we're going to talk about is tension. And tension is also a contact force. Again, contact is just talking about the fact that this force needs to be touching an object in order for it to occur. Tension is what happens when we have a string, a rope, or a cable that is pulling on an object. So again, imagine I have this box, but again, this time I'm pulling this box with a string or a rope. Because it's a rope, this time it's tension that is acting on this box. So tension is what's pulling it. Again, tension can only be present if we have a string, a rope, or a cable. Next, we have the normal force. And again, normal force is something that can only happen when an object is touching something. Normal force is also the one that people struggle the most with. And we're going to define a normal force as a force that is exerted on an object in contact with another object. So for instance, I have my box again, but this time my box is resting on a table. So because my box is resting on an object, there's going to be a normal force. And that normal force is just a force that is pushing back on that object. So let's think about it like this. This box is pushing down on the table. Well, my table is pushing up on the box. Normal force will always point perpendicular to the surface. Next, we're going to talk about air resistance. And again, air resistance is a contact force, meaning that air has to be touching our object in order for it to exist. Air resistance is just a fancy way of saying friction in the air. Air resistance is just applied by the air, and air resistance is going to point again in the opposite direction of motion. So it's going to slow down moving objects in the air. So let's say now we have a box just like we did before, but this box is falling in the air. So because it's falling, it's going to be moving downward. So its velocity is in this direction. Therefore, air resistance is moving upward on it. Air resistance is moving in the opposite direction. Force applied is just a contact force, just like we talked about before, meaning that something needs to be touching something else in order for this force to occur. And force applied is just exactly what it sounds like. It is a force that is applied by a person or an object. If you were to push or pull any object, you are applying a force to it. But don't get confused. If you push or pull an object with a rope, yes, you're applying a force, but you're applying that force to the rope. The rope or cable is really applying that force to the object. So an applied force occurs when it is you making direct contact to that object. Next, we have force spring, and force spring is a contact force. And it's exactly what it sounds like. Force spring is just a force that is applied by a spring that is touching an object. So think about So let's think about our pen, right? If I have my pen and I push the pen down, I can feel that there's a spring in there, and I can feel some resistance on my thumb as I push that pen down. Another example of force spring would be a trampoline. When we jump on a trampoline, that trampoline has springs. When I land on the trampoline, I'm pushing those springs down, and then those springs are pushing me back up. So when the springs push me back up, it's applying a force on me, and that's allowing me to jump up and down. And the force that it applies on me is a spring force. Our last force, and this is the most important one, is going to be gravity. And gravity is the only force on our list that's going to act at a distance. And what we mean by acting at a distance, we mean that gravity does not have to be touching an object in order for it to occur. So think about that, right? If I were to throw a ball up in the air, well, the ball comes back down. Is anything touching it in the air that's bringing it down? No. Gravity is a result of the Earth. The Earth is not touching my object when it's in the air. Since gravity is so strong, it can interact with objects by not touching them. So again, like we said, we're just going to define gravity as the attraction towards the Earth. And something really, really important to note about gravity is that it will always point down. So I'm going to go ahead and highlight just a few important forces that we're going to see over and over and over again. You need to know all of these forces, but these four are going to be seen a lot more than the others. So make sure that you definitely know these four. Now let's talk about free body diagrams. A free body diagram is just a way to show magnitude. And by magnitude, we're just talking about the strength or the size of our force. And it also helps us show the direction of all those forces acting on an object in any given situation. So we're going to go ahead and show what that looks like in a sec, but just make sure that you remember that our free body diagram is used to show the forces acting on an object. Very, very important things to remember here. The size of your arrow matters, okay? So size definitely matters here. And the size of that arrow reflects the magnitude, like we said before, meaning the size of our force. So the bigger our arrow, the stronger our force is. So for instance, a big arrow might indicate 100 newtons of force, where a small arrow might indicate 5 newtons of force. All right, make sure that the sizes are accurate to what we're talking about. If two things are equal to each other, they should have the same size arrow. If one is bigger than the other, then it should have a bigger arrow. There is no certain number of forces required. You can either have 1, 2, 3, 100, it doesn't matter. So here's an example of what a free body diagram looks like. Sometimes we use a square to identify our object, sometimes we use a circle. It doesn't matter which one, just so long as we choose something. Then we take our forces and we point them in the direction that they're occurring. So right here, I can see that there's a force applied acting in the rightward direction, a force friction acting in the leftward direction, normal acting up, and gravity acting down. I can see the sizes of these arrows and that friction and applied are the same size. I can also see that normal and gravity are the same size. We're going to say that balanced forces is what happens when these forces cancel each other out. So for instance, right here, since friction and applied are balanced, meaning that they're the same size, they're going to cancel each other out. We're also going to have unbalanced forces. And unbalanced forces are going to cause the object to accelerate in the direction of the stronger force. So if I had a bigger force applied here, it would mean that this was unbalanced, so my object would be speeding up to the right. Something important to note, though, about balanced forces is that they can mean two things. It can mean, one, that the object is at rest, or two, it can mean that the object is moving at a constant velocity. Just a quick example of what an unbalanced force would look like. Say I have friction acting to the left and I have force applied to the right. I can clearly see here that these forces are unbalanced. My force applied is huge compared to my force friction.